Hi friends, so in this video we're going to discuss about instruction pipelining. So instruction pipelining is one of the most important topic in computer organization and architecture. So in this video we are going to discuss three things. One is stages in instruction execution, and second one CPU performance, and third one is instruction pipelining timing diagram. So these three things we are going to discuss. One is, already in the previous videos we have discussed how many stages are required for an instruction execution. So these are the stages in instruction execution. First one is fetch the instruction, and second one is decode the instruction, and third one is fetch the data, and the fourth one is execution, and fifth one is the data store. So these are the in the next coming video we will discuss these are the types of micro operations within the instruction execution. So now you need to consider all these things are types of micro operations, right? So now these are the stages within the instruction execution. Now we are going to discuss how to improve the performance of the processor. So processor, always single processor can execute only one instruction at a time. But in deep, if you are checking that these micro operations are there, you need to consider that one type of micro operation can be executed at a time. So if you have one instruction, that is instruction fetch, can be executed or performed at a time with a single processor. Now how we can go for a performance improvement in a CPU, right? At a time only one instruction can be executed, but this will be considered. Now the diagram, you can see that if I am taking a 5 instruction example, right? So if I want to execute all these 5 instructions, you just consider that's a timing diagram, right? Timing diagram means how many clock cycles may be required. So if I'm having 5 instructions, for each instruction how many clock cycles may be required. So I'm considering that 5 clock cycles are required to complete one instruction. That is based on the 5 operations, right? So now if I'm considering all the 5 instructions, how many cycles may be required? Clock cycles. Now for the example, I'm taking that 5 into 5, so 25 clock cycles are required to complete 5 instruction with a single processor. Now if I'm going for the pipelining concept, right? Example, first instruction, I'm going to perform fetch operation first. During the second operation, that is a data fetch, right? After instruction fetch, and second operation is instruction decode. So now during the instruction decode, I can't perform same instruction decode for other instruction with the same processor, but I can go for another type. So I'm taking the second instruction. Now the second diagram, you can see that second instruction, I'm taking the fetch instruction for the second instruction. So now in the second clock cycle, for the first instruction, what's happening? Decode the instruction for first instruction. Decode operation is happening for first instruction, and fetch operation is happening for second instruction. So this is how you can parallelly perform operations, that is different types of operations parallelly. So if you're following this one, you can improve the performance, and same time you can finish the execution within a short period of time. But anyway, there is a disadvantages or some setbacks are there related to the pipelining concept. We'll discuss, that is called hazards. We'll discuss in the next coming videos. Now with this comparison, right, previous one, for 5 instruction execution, it requires 25 clock cycles, right? That is the first one. And second example, I am just using the instruction pipeline, right? Why instruction 1, instruction 2, instruction 3, instruction 4, right? For this, you can see that how many cycles are required. Now you can see that 9 clock cycles are required to complete 5 instructions. Right. So you can see that 1, 2, 3, 4, 5. After that, during the second clock cycle, I'm starting the third instruction, fetch instruction, right? And the third clock cycle, I'm fetching the third instruction. And fourth clock cycle, I'm fetching the fourth instruction. And fifth clock cycle, I'm fetching the fifth instruction. So this is how you can see that each clock cycle can perform different types of micro operation. Not the same operation, same type of operation, but different types of operation can be performed. So with the help of this one, you can improve the performance. Always you can reduce the time, right? Time of the particular instruction execution or program execution. So this is how your pipelining, instruction pipelining concept will work related to your processor and instruction execution.